in the worst case, they can be so productive, actually leading to the development of dead zones, okay, because of human influences, of the pollution, the eutrophication of the river water. Yeah, but that's a different story. So let's have a look at the next type of. These are known as shelf break fronts. Shelf break fronts. And let's have a look at one. And here we look at cakes again. Vertical transects, and you have 3 cakes. And you cut them and open and look from the side, and you see 3 different features. And on the right hand side, you can see the density structure. Again, sigma t, you have to add 1000, and then you get the weight of seawater per unit volume, per cubic meter in volume. Now you can see that here horizontally, these lines are contours. Colors can be misleading, okay, but if you look at it for a little while, you can see that there's lighter water here on the shelf. Then there's a transition zone, and this transition zone is approximately over the shelf break. This is what we call a shelf break front, and the current, the frontal flow, the geostrophic flow, runs along the shelf break. Very well-known feature. So just before you look at these other pieces of cake, is just we talk about what now creates the low density on the shelf, and then you look at salinity. Salinity here, let's have a look at salinity. At the value, salinity is lower on the shelf compared to the seawater. 33, okay, less than 33. Okay. Yeah, that makes sense. So it can create lower density, can it? Can create a lower density. But let's have a look at the temperature. And temperature, you think, oh, this is all warmer here. No, hang on, wait a second. Look at the units. Be careful, so don't rush. You always check the details. What's marked as red actually is only 4 degrees Celsius. So red, in this example, red is cold water and blue is warm. Okay, so be careful with that. The water on the shelf is actually relatively cold. So the cold effect, the temperature effect on its own would actually increase the density, but it's offset by the salinity effect. So the salinity effect is stronger. This is what creates the low density water on the shelf, is the salinity effect. Where does that come from? How do you get low salinity on the shelf? Probably know that by now. There must be some continental runoff, all right? Okay, so just a little attempt to explain why. It's all to do with Earth rotation again. It's to do with Earth rotation. And there's something that we call conservation of angular momentum. And what it means is there's something happening if you stretch or squeeze a water column. So for example, if you wanted to move the water from shallower water into deeper water, you have to stretch the water column. On the rotating Earth, what it does, it actually produces a rotation, produces currents. Similarly, if you want to move water from deeper into shallower water, you'd had to squeeze the water column. Again, this produces rotation. So you don't believe me? I mean, okay, so I can give you one example of how do you create this motion. So just think about an ice dancer performing a pirouette, and I show you a little video after this, just as a little entertainment part. Okay, so just imagine that a pirouette, yeah, an ice dancer with a pirouette, and just changing the radius of the arm, just squeezing the arms to the body will actually create a faster rotation. Okay, or stretching the arm gets it slower again. this is what happens in the ocean too. Okay? The reason is that the Earth is rotating, so you already have some rotation. And then if you squeeze or stretch the water column, it does the same. It actually expands horizontally or shrinks horizontally, and it's equivalent to what happens to an ice dancer. So this is what happens here. This is why these shelf break fronts tend to run along the shelf break, because the currents that are created if there's a disturbance move the fronts back to the shelf break. Sounds fascinating, doesn't it? And I just show you that little video now.